Hello everyone, this is Adit back again with another video. So in this video, we are going to learn about searching algorithms, and we are going to mainly focus on linear search and the binary search as well. Okay, so let's get started now. Like for the binary search, I'm pretty sure you guys are already aware of it. Like if you are not new to the programming. So if we just have an array, we are going to use these values. Let me just copy some of the values. Uh, Side it. Let's suppose we have this array. Okay, so in linear search what we do is we have an array, and we have a value that we will try to search inside that array, and if we find that value, then we will just return its index. Okay, so and this will just like simple for loop. So let's just do that. Let's have a function. Okay, and this let's just called linear search, and this expects an array as well as key. So basically the key is the one that we will try to find out inside that array. Okay, so in case of linear search, it's pretty simple. We're just going to have a for loop which is going to have 0, and I should be less than here dot length I plus plus. Okay, and if we find arr dot I is equal to key, then we are just going to return the I. And in case we don't find that, we'll just return -1. Okay, and if we try to run this now, let's just console log. I think I have misspelled it. Let me just copy it over here, and let's just pass the array. And let's suppose I want to find out 130. Okay, and let's just save it. And once we run the code, so it should be len zth length. Okay, and now we run the code. We are have to get 8 over here. So basically the 130 is present at 8th index. So basically if we just go 0 1 2 3 4 5 6 7 8, so it is present at the 8th index. And now the time complexity of this linear search is obviously like it's a on big O of n, where n let me just write it right, stays big O of n, where n is the length of array. Okay, so this is for the linear search, but this video is all about binary search first. So we will now focus on the binary search. And I just wanted to have both searching algorithm. Like this is the first tutorial on the searching algorithm, that's why I just wanted to put the linear search as well. So now we are going to have a binary search as well, and we will try to implement both of the binary search using recursion, and we will also implement it with the iterative solution. Okay, for the binary search as well, we will use the same array, and I'm just going to keep the code for the linear search as well. And below over here, let's just call it binary search. And now let's have a binary search. And first of all, let's just have it in a recursive recursion, and let's just have function binary search. And this expects four things, and that is one is array, and second one is left, right, and key. Okay, so how the binary search works is, if we have an array, like let me just explain that to you as well. Like if we just have an array, okay, so in this array what we are going to do is and one more thing that is really important, that binary search only works on the sorted array. So this array should be sorted, and after that, what will happen is like we will index the mid element that is present inside the array, and we will compare our key with that mid element. Okay, so in the first case, what we will have is this one will be the mid element, right? This 4. So we will compare key with this 4. Okay, and if this 2 matches, then we are just going to return the index. And if in case this does not match, then we will check whether the mid element is greater than key or less than key. If it's like if the 4 is greater than key, then obviously we need to go to the left side. Okay, then we will compare all the elements from the left side. Okay, and our mid element will change to this one. Sorry. Okay, and similarly, if 4 is less than key, then we will go right side. Okay, and we are just going to compare, then we are just going to compare it from the mid element to the end of the end of the array. Okay, I hope that's clear. So now we are going to implement it. So first of all, let's just find out the mid element of our array. So let's just have mid, and to find the mid element, what we can do is let's just have right, left plus right by 2, and I'm just going to wrap this inside let me just put it inside the bracket, and I'm just going to wrap this inside the math.floor, because we don't want any value to be in decimal, right? We want the whole numbers over here. So we have our mid element, and now we will, from the mid element, we will check if our mid element matches with the key. So let's just have array dot mid. If it matches with the key, then we will just return our mid. Okay, so this is the simple case. Like if we find it at the mid element, this will be the easiest one, and then we will just return the mid index. If in case we don't find at the mid element, and then we will check if the mid element is greater than key. Okay, if this is greater than key, then like this one is the case for 0 to mid element. Okay, so if the mid element is greater than key, then we will just run the binary search again, but we will update the value. So what we are going to have, in place of left, we are going to have 0, but in place of right, we are going to have mid minus 1, and mid minus 1, and key will remain the same. Okay, and similarly, else if array dot mid is less than key, then we're just going to return binary search array, and for the left, now the left, our left will shift to over here, over at 4, at after 4, right? So left will be mid plus 1, and then our last element will be array dot length, and the key will remain the same. Okay, and now let me just put the comment for this one as well, mid to end. And now if we just try to run console.log binary search, and over here we just pass our array, and left obviously will be 0, and right will be array dot length, and key, let's search for 130 over here as well. Okay, and now if we just clear our console first, and we just comment this one. This one was for the linear search. And now we will just run this, and we have to find the index of 130, which is at the position of 8, 0, 1, 2, 3, 4, 5, 6, 7, 8. Okay, so this is how our binary search is. We will implement the binary search in recursion, and the time complexity of the binary search is O log n. So here n is the length of the array, not length of the array, but n is the number of element inside an array. So yeah, and similarly we can implement the binary search in iterative solution, iterative way as well. So let's just have it in, just comment this out first, and now we are going to have a function. Let's call it binary search again, and this one will be iterative solution. So we are going to similarly we are going to get our array right, left. Basically, you can call it start and or end as well. That will be more descriptive, I think. But right, left will also work. And now, what we are going to do over here, we will in iterative solution. What we do is we update the left and right actually. Okay. So we will run a while loop over here, and we will check if the left is less than equal to right. Once left increases or right or left is equal to right, then we will stop the our while loop. Okay, so let's have our mid element. That is again going to be mat dot floor, and left plus right by 2. Okay, and similarly we're just going to find if we have the mid element as key, then we're just going to return mid. And if we are not able to find our key at the mid element, then what we're going to do is we're just going for the mid less than key. If it is less than key, then again the case will be we are going to have from 0 to mid. Okay, and here we will update the left value to mid plus 1. Sorry, not actually, it is from not from the mid to 0. It's actually from if array dot mid is less than, then obviously the our key will be either in greater side, right? So it will be from mid to mm, total. Okay, and similarly if we just have array dot mid is greater than key, then we are going to have the case for 0 to mid. Okay, and then there we're just going to update right mid minus 1. Okay, so it will go if you just look into this array, just paste it over here, so it will go below 4 over here. Right will shift to here. Earlier right was here, but it will move to over here, and then we will do the we will find from this one by using the same similar approach. Okay, And in case we don't find anything, we just return -1. And now let's just run this one as well. We just have array, and left will be 0, right will be array dot length, and our key. Let's put 130 over here as well. Let's just clear the console. And then if we just run our code, oh sorry, it should be console.log. And let's just clear the console again, and let's run our code. So we are able to find it, the index of that element. We are at index of 8. And so this is how we implement the binary search or linear search in JavaScript. So this is it for this video. If you like the video, consider subscribing, and thank you for watching.